This is Suvarchala, working as an associate professor in the Department of Computer Science and Engineering. In this session, I'd like to discuss about how the data will be accessed from our secondary storage device. What are the various techniques are there to access that particular data? How the data has to be stored in the form of a file. That is the organization. The methodology of records organized in secondary storage device. What are the various techniques are available, and these techniques, pros and cons of these techniques will be discussed in this lecture. This session includes the file organization techniques and what are the various methodologies of organizing the records in files, data dictionary storage, and index file organization. So what is file organization? The database is stored as a collection of files in the secondary storage device. We define our database as a collection of data which is interrelated and accessible simultaneously by multiple users. So the data has to be stored internally in secondary storage device. In which format this will be stored? It depends upon the secondary storage device capability as well as the way we are storing the records. The database is stored as a collection of files only. What is a file? File is also a collection of interrelated records. Each file is a sequence of records. A record is a sequence of fields. This is the hierarchy. Field is similar to your attribute, which consists of a unit of data will be stored in our field. So the same base structure of our database storage is again file organization only. Various approaches are there depending upon the size of the record, etc. Size of here in the record is analogous to our tuple. File means analogous to our table. Similar to that, we can compare how the data is going to be organized in our secondary storage device. So various approaches are there. One of the approaches, assume the record size is fixed, that each record will have the fixed size. Each file has the records of same type. Different files are used for different relations. This case is easiest to implement and will be considered as a general form of the representation of our file organization. So that means this is the common approach we will follow. So in first case, you are going to represent the data is going to be having fixed size of record. Each record will have the same size whether it is utilized or not, of the same type, and each file will have the same type of data. So that's why different types of data or different types of relations are stored in different files. But always it is not possible, but we'll discuss how the variable length records are going to be stored also. So in this simple approach, store each record I starting from a byte and star I minus 1 where n is the size of the record. For example, size of the record is 30. The first record starts at 0 byte. Let us assume that. Second record will be 30th byte. Our first byte it starts, second record 31, third record is 61 and so on and so forth. So that's why n star I minus 1 is the starting record, starting position of the ith record. But remember in this example, n is the size of the record, each record will have the fixed size as n. The record access is simple, but records may cross sometimes blocks. Because already we know that the data is going to be stored in form of the blocks in secondary storage device. So it may cross block, but the size of the record is going to be fixed. Depending upon the size of the block, depending upon the number of the records we are storing, a file may occupy more number of blocks. Because of that, a record may store in more than one block depending upon its position, etc. How the data is going to be modified? Modification allows the records to cross block boundaries also. How the record is going to be deleted? If there are various approaches are there. Once a record is deleted, all the remaining records, that is downwards, that particular records are moved upwards. That is one approach. But it's costlier process, or pointers are going to be used. So whenever a record is deleted means the deleted space is going to be sent back to the free space pool. Because moving of multiple record, for example, if we are removing a record number 2 and that file consists of 200 records, then 197 records have to be moved upwards, which is a expensive process. So that's why you observe here a table was given and record 3, this is the table. You observe the record. Record 3 we are going to delete. So record 3 if you would like to delete, this is the 2222. This is the record number. This is going to be deleted. If it is deleted, 32343, the next record has to come up like that. So you observe record 2 is deleted, that is record 3 is deleted, 4 is moved to the third place, 5 is moved to the fourth place, and so on and so forth. But so many records have been moved, no? It's an expensive, costlier process. So that's why another technique we can use, deleting a record 3 and moving last record. This is another technique. Generally it happens. If it is not maintaining the sorted order of the data, it is possible. Whatever the last record is there, that is moved to the deleted position. So last position is going to be free, means from there onwards anyway free space might be there. So you observe here, third record deleted means in third position, the 11th record came into the third position actually. Now, whenever, if you are using in both cases, for example, if the data is in sorted order, deletion of a record, moving record, last record to the deleted position may generally disturbs our ordering actually. So that's why another concept is there, as I explained you, free list will be there. Generally, the free space is going to be maintained by a pool known as a free pool or a free list. This free list is going to be, because whenever data has to be stored in some location, first the free list is going to be checked where the free space is available and the respective space is going to be allocated to the storage. So that's why store the address of the first deleted record in the file header. So that what happens, the remaining are going to be connected further. Use this first record to store the address of the second deleted record. Then second deleted record is going to be pointed to the third deleted record, and so on and so forth. So that what happens, all deleted records space is going to be pooled as a free space actually. So more space efficient representation, and whenever we would like to insert the data, if possible, we can use this free space while inserting the records. So free space is efficient representation which can be reused for normal attributes of free records to store pointers. Now you observe, first record deleted, it is a header, and record 1 deleted, a pointer is pointed to this. Next record 4 deleted, then pointer points to the fourth record, and so on and so forth. So once the deletion is over, the last record points to the null. That means after that no free space is there. So when I would like to insert, the last record I may store and the previous record becomes null, the data will be inserted in the free space also. So by using this pointer concept, addresses are as pointers. These are going to be pointed, the free records are pointed one as a chain of free records and be maintained in a free loop actually, free pool. So this is the way how the fixed length records are going to be stored. Most of the time our database consists of the fixed length record only. But what happens no, whenever the data is going to be stored, data need not be fixed. Because of these fixed length records, some memory is going to be get wasted. Initially, we may think that memory space is not that much, considerable. But what happens no? Voluminous of data we are maintaining in such cases, that type of memory, that such memory, all pooled memory is going to be considered to be as a voluminous memory is getting wasted. So that's why even in our database representations, whenever character type data is going to be represented, it can have a data type as a varchar. So varchar means, for example, I am using a name. So generally name can be considered as a for 40 characters or 30 characters, etc. Because the name length depends upon the person to person varies. But all names may not occupy the 40 characters, no, 40 bytes. Only some of the names are going to be occupied 40 bytes, but the remaining attributes are going to be, some of the attributes are, sometimes it may occupy 4, for example, Jan, right? So, Ram, 3 characters. Like that, only 3 bytes, 4 bytes are allocated. If it is a fixed, what happens? 37 bytes or 36 bytes of space is going to be get wasted, filled with blanks. So that's why to avoid the such type of wastage of memory, this varchar is going to be generated. So that what happens if the particular attribute is having only occupying 3 bytes, only 3 bytes are allocated, remaining 37 are not going to be allocated. So in such cases, what happens? The length of the record is going to be varying. For example, the record consists of, let us assume that all ticket number is 5 bytes, name is 30 bytes, and pass or fail is 1 byte. Okay, these two are fixed. All ticket number, pass or fail, yes or no will be fixed. But name is represented by using this varchar. So, for example, if the name consists of only 4 characters, what is the size of the record? 5 plus 4 plus 1. That is, it will be 10 bytes. If the name is 20, then what happens? 26. If the name occupies 15 characters, 15 plus 6, 15 plus 5 hall ticket number plus 1 for our pass or fail. So 15 plus 6 means 21 bytes. In this example, you observe the record length is varying, not fixed. In such cases, how the data is going to be stored and how the data will be accessed. So variable length records arise in database systems several ways. Storage of multiple record types in a file. In a file, each record may not have the same type in such cases. And record types allow variable length attributes like varchar, just now I explained you. Record types that allow repeating of the fields. For example, marks. Instead of storing marks, M1 occurs 6 times. Or M1 occurs some end. For example, first student appears only 2. Then what happens? M1 means marks are going to be having M1 of 1, M1 of 2, only 2. If one student occupies or supports, appears 6 subjects, then M1 of 1, 2, etc. 6. So totally this is the process of working of the respective records actually. So whenever we are using these kind of variable length records, how the data is going to be stored. As usual, attributes are stored in order in which they are going to be stored. In case of variable length attributes represented by the fixed size, that is offset length, which actual data stored after all fixed length attributes. And between each two consecutive records, a one field is going to be used as the end of the record because it's not fixed, no? So that's why some bit mapping, null bit mapping is going to be considered, and one byte data can be occupied for this, which indicates that the end of the record actually. So that's why we will read it till end of the record means record completed, next record started after the end of the record. Now you observe here 21 comma 5, right? So 26 comma 10 offset and length is there totally. So total 21 means 5 used, 26 10 and so on and so forth. It is going to be considered. So 5 used no, so that's why up to 4. Okay. So up to 10 you are using no, so up to 8 and so on and so forth will be considered. So null values are represented by null value bitmap. These variable length records are also stored in the form of a slotted page header. So that means slotted page structure. So slotted page structure means here, in case of operating system, the data is going to be stored in the form of pages, no? Memory is going to be represented in the form of pages. So that means page means some amount of memory here. We will represent that particular page as a slotted page. So each page consists of number of records depending upon the size of the page, depending upon the number of the, size of the record also. So that's why how will you arrange your records in each page? In this structure, we are going to consider the records can be moved around within the page to keep them contiguous so that no empty space will be there between them. Entire empty space will be just after header and the remaining data will be stored. Data will be stored after this free space actually. That means the data will be arranged in such a way that the free space occurs at the beginning of the page only after header. So that what happens that we will start searching for the records if the record exists or if the record deleted, the deleted is going to be added to our free space. Because it's a page, no number of records are not that much high as in case of file. The remaining records are going to be moved or packed so that what happens, free space will be at one location. In this slotted page, the header contains this information. What are the various information provided by this header of the page, slotted page are number of record entries. That means it will give how many records are there and the end of the free space in the block. After completion of the header, free space starts. Where it ends free space, that pointer will be there. And also, it will give the location and the size of the each record. Location and size means it will point the pointer to the respective record actually. Now you observe here, this is the specified way. This dotted line represents the free space ending and the remaining are the 1, 2, 3, 4 are pointing to the 4 records actually. That means this will give you the position of the respective record as well as how much size it occupies. These two are going to be represented in the header file actually. So this header file is going to be specified properly. Header is going to be specified properly, which indicates us how many records are stored and how the records are going to be packed properly. For example, if any record deleted, what happens? The remaining records are moved there and free space is going to be allotted as a single contiguous free space. Then according to that, pointers are going to be updated. So this is the way the variable length records are going to be managed by using various techniques depending upon the organization. The respective approaches are going to be selected by the developers or designers. So how the data is going to be organized in file? Because our just initial concept is depending upon the organization of the data in our file. According to that only, the remaining operations are going to be carried out. The data in a file can be organized by using various techniques. Heap organization will be there, sequential organization, hash indices organization, or normal indexing, order indices organizations are there, and the multi-table clustering organizations are there, indexed sequential organizations are there, and so on and so forth. So depending upon our need, because each of these approaches are having its own advantages and disadvantages. Depending upon our need, we will select the appropriate organization technique to store our data in the database. Heap, a record can be placed anywhere in the file where there is a space. Heap means just like a pool. Of course, they are going to be having some techniques of how to connect to each other. That is different. Sequential. The entire set of records or group of records are going to be stored in a sequential order based on the value of the search key of the each record. That is, it is stored in the sorted order of the key value actually. Hashing. Hash function is going to be computed on some attribute. We will consider it as a key attribute of each record, and the result will specify the address of the block where the respective data was stored. Address of the block or a bucket. Terminology is going to be changed where that respective record was placed actually. And multi-table clustering file organization gives records of each relation may be stored in separate file, but this kind of multi-table clustering file organization manages or stores records of several relations, different relations in the same file. So generally it happens when the related records on the same block to minimize the IO organization actually. These various kind of techniques are available, various kind of approaches are available so that we can select as per our need. Once you understand all these techniques, selection of technique to store our data will be very, very easy to us actually. So we'll discuss one by one, a little bit brief. And sequential file organization, it is suitable for the applications which require sequential processing of the entire file. I'll give an example. Print details of all employees. That means each record has to be processed, no? Then sequential. Such type of operations are very suitable if the data is stored in the sequential organization. Process the student results. Every student results have to be processed, no? So that's why in such cases also, that means almost all records have to be accessed. In such cases, sequential file organization is more useful. In this organization, the data or records are going to be stored in a file ordered by the search key, and a pointer is going to be pointing to the next record. So it's diagrammatically represented, but it will be one field will be there which consists of the pointer of the or address of the next record and so on and so forth. It's a link so that the data can be accessed in a sequential order. So various operations can be done in the sequential order. A record can be deleted or a record can be inserted. So insertion means here, if you would like to insert the record, because all the data are packed one by one, so we will insert a record in a free space and pointers are going to be changed. That is, addresses are going to be changed. So now you observe here, this record has to be inserted. What is the position of this 3, 2, 2, 2, 2? This can be placed in between 1, 2, 3, 4, fourth record and fifth record. Because fifth record key value is 3 to 3, fourth record key value is 2 to 2 started. So in between this 3 to 2 is possible. So in such cases, if you would like to insert from fourth record, the pointer is going to be pointing to here. Pointer modifications are enough. Just links are going to be updated. And link of this is going to be pointing to the next record of the previous one. So 3 pointer updations are enough. So 5-2's record pointer is pointing to the 32343 actually. So now this is going to be 32343 is going to be pointed by this new record, and 5-2's record is going to be pointing to this new record. So total only updation of the pointers automatically makes our records are in a sequential order. For example, if no free space is there, insert the record in a overflow bucket, and if any free space is there, for example, in between already deleted free space is available as we discussed earlier, in such cases, it can be inserted there in the respective place if the place is correct one, so that the ordering of the data may not get disturbed. Otherwise, a new space is allocated, that respective pointers are going to be updated. Similarly, deletion, these any pointer, any record has to be deleted. Just deletion record is nothing but previously from whichever the point record it is pointed, that pointer is pointing to the next record of this deletion. Just point. And deleted space record is going to be pointing by the respective free space pool. So need to reorganize the file from time to time to restore the sequential order. Sometimes it is a disadvantage actually. So another kind of a file organization is a multi-table clustering file organization. In this multi-table clustering file organization, various tables are going to be stored as a clusters. For example, you observe this department and instructor. Department is computer science department. Instructors, multiple instructors are there. So that's why here, department computer science, you observe here, for computer science, how many instructors are there? All their instructors' details are stored at one location. You observe Taylor, 10,000 and 45564, K8 card, computer science, and 75,000 salary. Right? Next, Srinivasan. Next, Ravi. These are the, because 3 records are there in instructor, all those 3 records are connected to this computer science pool. What is the next record? Physics. So that physics record is having another employee in the instructor after physics details, department details, that is connected. That is, the clustering is made depending upon the department here. For each department, the building, the details of the department as well as the respective employees belongs to, employees means instructors belong to that particular department are going to be considered. So you observe here, it is stored here, computer science is the one pointer. All other details are, all other connected details are clusters related to computer science only. As long as a new department occurs here, physics department occurs, that is after computer science, physics. After physics, any department is there, it will be connected. If no department is there, null pointer. Why this type of organization is needed? In which cases these type of organizations are suitable? For example, in most of the queries are involving these multiple tables, same multiple tables. For most of the queries, frequently asked queries are based upon these 2 tables. Then storing such type of data in multi-table clustering file organization is effective. Why? Because the query processing time is going to be drastically reduced. So that's why at the time of designing our database administrator must understand what type of queries are frequently accessed or how the data is going to be accessed. What type of queries are, expressed to access our data most frequently. Based upon that, the organization has to be selected by them. So good for queries involving both tables and for queries involving one single department and its instructors. Combination of queries are there, then it's better. And this type of design is not suitable for the queries which involves only a single table. Remember that. Results in the variable size records, because one record is mapping with the group of the other table records. No, so that's why what is the size of that group we don't know. So that's why variable size records, and pointers are going to be added to link the records of particular relation. Another technique is there. We will call it as a data storage technique, as a data dictionary storage. This is most important because the data dictionary means this is also called as a system catalog, or which is used to store our metadata. Metadata means data about the data. Not this is the actual data, but the details about the data which has been stored in our database are going to be stored. It seems to be not that much relevant actually, but it is more important and a crucial process of managing this data dictionary. And lots of research was going on how to store a data dictionary effectively and how to access data from the data dictionary is also more important. So this data dictionary stores metadata, data about data, and for example, it will store information about the relations. That is, information means names of the relations, names of the attributes, and the names of the attributes, the type and the length of the attributes, etc. Each relation, and any views are defined, any triggers are defined, any procedures are defined, what are the constraints are defined, and when it is defined, when it is updated, all this entire information is available, size of the relation, etc. So user and accounting information, users information, accounting information, which relations are used more frequently, how much time they are using, who is using, all this accounting information, passwords, etc. are all stored actually. And also it will maintain statistical data. We'll discuss the importance of the statistical data in our query optimization also. When a query is going to be request, that is the access to request to access some data from our database, how efficiently, effectively that query is going to be processed is based upon the query processing and optimization techniques. There, this statistical description of the data is very, very important. That is, what is the mean, average, how many records are there, what is the size the respective relation occupies. So all these are going to be stored actually. And physical organization information also will be stored. Just now we are, how the data will be stored, sequential order or indexed order. If it is indexed, which key attribute is primary key, secondary key, all this information is going to be. If it is a hash indexing, what is the hash function used, how many buckets are there, entire information is going to be stored. And also it will specify where physical location of the relation exists also actually. So that's why this data dictionary is going to be represented more effectively, and so that data about data can be accessed very fastly. This data dictionary is also represented by using relational approach also. That is, relational means each area of the data dictionary is represented as a relational representation. That relational representation of metadata will be on the disk, and not only relational representation, specialized structures are suggested by various researchers, and those data structures are going to be used to design our data dictionary so that the efficient access of the respective data can be considerable ways. So in the relational representation, you observe relational metadata, relation name, etc., index metadata, view metadata, attributes metadata, users metadata, and so on and so forth. And those are going to be having connections among themselves as relational database management system, so that multiple tables also considered whenever requested for some data. And will be stored, database file is partitioned into fixed length storage units called blocks. And also we discussed in the previous lecture also how the secondary storage device, that is magnetic disk, was manageable. Blocks and everything, sectors, tracks, we discussed there actually. Blocks are the units of the storage allocation and data transfer. This database system seeks to minimize the number of block transfers between disk and memory. That is one of our criteria actually. So that means the number of block transfers between our disk and memory has to be reduced, so that what happens? The access time can be reduced. So to reduce that, whenever we are transferring some block, it has to be maintained in our buffer, that is in primary memory. So that's why to store in primary memory temporarily, we will use a buffer. So what is a buffer? Buffer is a portion of main memory available to store copies of our disk blocks. And buffer manager is a subsystem which is responsible for allocation of the buffer space in the main memory. So this buffer manager will take care of what is the size of the buffer, how many buffers are there, how the data is transferred from buffer to disk and disk to buffer, and it will maintain the free buffer space. Everything is going to be manageable by this buffer manager subsystem. So this buffer manager is a program calls on the buffer manager when they need a block from the disk. So if the block is already in the buffer, for example, while writing a program, I may be requesting some input data. When I'm using this reading option, a reading statement, the data has to be read from our secondary storage device, that is database. Then in a program, if they need a block from disk, if the block is already in the buffer or not, it will check first. That is, respective data is there in the buffer or not. Buffer manager returns the address of the block in main memory. If it is not there, what happens? If the block is not there in the buffer, then buffer manager will take care of this transferring secondary storage device to primary. So that means first what it's supposed to do? First it has to allocate sufficient space in the main memory. That is, buffer block has to be assigned by the buffer manager. If it is available, it will be allocated. For example, if it is not available, what it's supposed to do? Already existing buffer must be emptied. That is, replacing or throwing out some other block if the required to make space for the new block. So how to replace? Some techniques are there that we'll discuss. That replaced block is going to be returned back to the secondary storage device, and space is going to be allocated to the new block to be loaded again. So it has various techniques which block has to be get emptied, and these are called as a block replacement techniques. After the allocation of the space, then it reads the block from the secondary storage device disk to the buffer allocated, and it returns the address of the block in main memory which is requested. So which block has to be replaced? Buffer replacement policies are there. Most operating systems replace the block least recently used. Right? Which is not recently, which is recently used means it may not need further immediately. That is the idea behind LRU. Use past pattern of the block references as predictor of future references. So, which is used to not used to quite a long period of time, that block is going to be replaced generally. And various queries have well-defined access patterns. Database can be use the information in the user's query to predict the future references also. Of course, it is not a good strategy. It has its own disadvantages. But what happens now? Simple, it is very simple. And many other strategies are also there actually. So LRU can be a bad strategy for certain access patterns involving the repeated scans of the data. Sometimes we want to access the same data quite a long period of time, number of times to be accessed. In such cases, this may not be suitable actually. That's why the strategies are going to be various strategies are going to be suggested depending upon the need. Respective strategy can be used by the database buffer manager, so that what happens, the query optimizer may be supporting the optimization process. So that's why other types of buffer replacement policies are pinned block, toss immediate, most recently used or least used recently used, which we discussed. All these are some of the buffer replacement policies. Pinned block means memory block that is not allowed to be written back to the disk. Toss immediate strategy means it frees the space occupied by a block as soon as the final tuple of the block has been updated. Most recently used strategy means the system must pin the block currently being processed, and after final tuple of the block was processed, the block is going to be unpinned. So during any process, it should not be replaced. No, that's why we will use this technique as a pinning means automatically it cannot be replaced. So that what happens, it becomes the most recently used block. Buffer manager can also use some statistical information regarding the probability of the request will be with reference to the previous history also. Buffer manager also support forced output of blocks for the purpose of recovery techniques. Sometimes in the recovery techniques also we discussed already. So during the recovery process also the data from the blocks are going to be forcibly sent back to our, depending upon the recovery technique, sent back to our secondary storage devices, as well as the log files are also sent back to our stable storage devices forcefully. Right. This is another organization, so that buffer manager will take care of how the data is transferred between secondary storage device and primary storage device. Another kind of organization is their index file organization. We will generally term it as an indexed sequential access method, ISAM. This is used more frequently in our file organization techniques. Index are used to speed up the record retrieval in response to the sudden search conditions. Whenever we are using only sequential on a key attribute, based upon key attribute, the data will be stored. But in case of indexed organization, on any attribute, we can create indexing, so that accessing the data can be made as a faster way based upon any kind of search condition. Any field can be used to create index, as well as multiple indexes can also be considered. So most index-based organizations are based upon the ordered files, and tree data structures also organize the indexing structure. Multiple techniques are there actually. So single level indexing will be there, multi-level indexing will be there. Various types of single level indexing techniques are there. So that's why single level ordered indices will be there. Ordered indices means similar to our index in our textbook. That means this particular topic is available in the first page, second page, third page, etc. That means indexing is going to be done on a particular attribute. It creates a separate file, index file will be created, which consists of only two fields. One is index attribute value. Second one is address of the respective record. That is the pointer to that particular record. So it will be stored here generally most of the time. Indexing is going to be whenever you are doing indexing on a particular attribute, an index file is created, a new file having only two attributes. Based upon the binary search algorithm of this index file, we can access the respective record from our secondary storage. The search process will take almost same time irrespective of the position of the record. So values in the index are going to be in order. Primary indexing is specified on the order key field of ordered file of the indexing. Cluster indexing is there. Secondary indexing is also there. Cluster indexing means numerous records can have the same value in order field. Then we will call it as a cluster index. That means an attribute. For example, if I am going to index based upon course name, students data. Cluster, course name, for example, CSC. All CSC students will come under a group, no? So that is one cluster. So for a particular key value, multiple records are existing, that is cluster indexing. Secondary indexing means it will be specified on any non-ordering of the attribute also. Data file can have several secondary indices also. So, ordered file with two fields will be there, as I told you just now. Primary key will be there, pointer to the disk block. Key value, respective address, where that particular data was stored physically, that address will be there. One index entry in a index file for each block in the data file will be there. Indexes may be dense or sparse. Dense indexing means here, index entry for every search key is there. That means it is a dense indexing. That is for 100 records are there. 100 search keys will be there in our index file. Then it is a dense indexing. Sparse index means our index file doesn't consist of all records. It will consist of only a few records, so that in between a group of records are going to be searched for. So for example, here primary index, you observe for each record of name, one index was created. Adams, E.D., Adams, John and Alexander, etc. are there. This each one index was created, but you observe in this is the first part of the, this is the index file, consists of key value and address. This is key value, but these key values are in order, sorted order, and the respective position will be there, pointer. So first we will search the sorted order, small size file. Then by using some binary search or efficient search technique, we will find the address, then we'll go. So the time taken to access any record will be almost same. So what is the major problem of this indexing is insertion and deletion of the records may take more complexity. Move the records around and change the index values every time. Reorganization of indices is going to be always to be considered by us, which is expensive again. So that's why use unordered overflow file, or we can use linked list also overflow records, so that indexing can be done more effectively for other operations also. Clustering of the indices and ordered file with two fields, same type of the cluster field and disk block pointer can be used for our indexing actually. So now you observe cluster ID will be there, for the cluster address is given. For the department CSE1, department 2 one group, department 3 one group and so on and so forth. Secondary indices will be there. It will provide secondary means first index value is the same, then secondary indices is going to be considered actually. You observe here, hash index is also one of the secondary index. So this is the first index which will give the secondary indexing, then it will be considered. Generally, secondary index will be dense indexing with block pointers in a non-ordering key attribute value. Various types of single level order indices and the respective properties are represented here. In case of primary, number of blocks in the data are going to be file, and dense or non-dense means it is non-dense means sparse. Block authoring on the data file is possible actually. Similarly, clustering, secondary key and secondary non-key indices are there actually. More indexing techniques will be discussed in some coming sessions. Indexing on multiple keys, and based upon which we will discuss B trees and B plus trees in the coming sessions. Dynamic indexing on multiple keys are represented by the B plus trees also. Hash indices, bitmap indices, grid indices, indexing on physical and logical database design, and tuning of indices is most required condition to make our database more effective while accessing our data from the database actually. Thank you for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.